So hello, everyone. I'm Charles Ruffino, Technology Fellow in the Cloud Architecture Group here at SoftIron, and here to talk to you guys about HyperCloud. Hey. All right, so what is it that we even do? And the what really here is kind of simple, actually. It's quite simple. We make cloud-native infrastructure. It's built to give you a cloud, a private cloud in your own data center that you own, instead of all the usual other things where you have to pay somebody else to deal with some things. You have the ability to finally do what needs to be done from that ease of use and usability standpoint. Now, you've probably heard this a million times in the past, right? But 90% of the solutions that are out there that claim to be a private cloud are really nothing more than virtualization. So what does cloud native infrastructure really look like? It's kind of a bunch of this, right? You think of all the properties that kind of make up that cloud native place or space. It's and really everything that's on premises today is kind of a component of what that private cloud is anyway. It's just usually from different vendors, and kind of trying to cobble those pieces together, it tends not to work in an effective manner, right? And the reality is the hyperscalers are all doing the same thing, except they have quite a massive scale and quite a massive talent pool, and they make that infrastructure really look opaque. But this is the architectural burden that we've all been dealing with for arguably a couple of decades now. And it's very, very difficult to kind of get past. People tend not to think about what's underneath and the way that these things are supposed to work. But this is ultimately the thing that we've been trying to get to, and what the hyperscalers have really shown us is that there is a desperate need for this consumption type of capability. People want to reduce their IT complexity, and they want to increase their IT agility in general, right? And so to be able to do that, it takes a little bit of work, arguably a lot of work, in order to get there. And this is the thing that we're talking about here. So one of the things that Jason mentioned in the previous session was the marketplace here, or the service catalog. The point here is to get to your outcome as quickly as possible. Having all of the underlying pieces that really get you to that stage has traditionally been very difficult. And I think it's been by design in order to kind of make a bunch of other organizations very rich, which is great. It's good for the economy in general, yeah? But at the end of the day, lots of businesses want to get to their outcome as quickly as possible. And that's what we're here to help with from a HyperCloud standpoint. Now, back in the day, the mainframe was the de facto way to do computing, right? And then came the server, and everyone said, oh, the server is going to kill the mainframe. Then came the notion of virtualization, and everybody said, oh, the hypervisor is going to kill the server, which was just a testament to the fact that they didn't understand how technology worked, but don't tell anyone. Then came the container, and everyone said, oh, the container is going to kill the hypervisor. And then came the microservice, which again, they said they're going to kill the container, which don't tell anyone, but containers or microservices typically run in containers, and it's all running on a mainframe. Or the modern version of that being a server or a cluster of servers, right? And that same progression has really happened in the data center, to the point where everyone said, oh, the cloud is going to kill the data center. But don't tell anyone, it's just a data center, it's just not yours. But again, that desperate need for the experience is the thing that has been really surfaced with all of the cloud-based solutions. Now, of course, with constant changes in IT, again, as I mentioned, there's two very specific things that businesses are looking for, and that's to reduce their complexity and increase their agility, to get to their outcomes, their business outcomes, as fast as possible. And so that's the whole purpose of really moving to the cloud, or at least the thing that the cloud has taught everyone, is that you come to us and we'll help you realize your outcomes as quickly as possible, which is true in some cases, but there's also the hidden pieces that tend not to work. So there's usually 4 reasons why businesses can't move everything to the cloud, and it's typically these 4. So from a security standpoint, obviously you think of your sensitive or regulated data, your financial details, healthcare related information, or maybe as a business you're actually competing with the cloud-based providers, and you don't want to put any of your intellectual property in their cloud, because there is the chance they may borrow some of that, if you will. right? Then you have your data sovereignty or data residency, where you have to have something in a particular location geographically. And then, of course, there's performance. While the cloud is very powerful and is providing a lot of ease of use in things, there are sometimes when you just have a ton of data and you need to do all of your analysis in-house, bringing it home. And then lastly is repatriation. While there may be some arguments there about the amount of things that have moved to the cloud already and need to come back, there is still that nature, right? The mad dash to the cloud was something that we needed to kind of pull back or peel back a little bit, and so maybe the legacy app just doesn't work appropriately in that environment. Now, as mentioned in the previous session as well, as a business, we really think that security and authenticity needs to be assured before including any of our components in our any of your mission critical systems. And so we build and design everything from the ground up, from the printed circuit board all the way to the final software release and everything in between. To that end, everything kind of at the bottom of this slide, we're really security focused here. So we're FSMA high, FedRAMP high, DoD-SRG, impact level 5 compliant and deployed for secret classifications. We can run as a fully air-gapped cloud with no connectivity to the internet at all, without diminishing any of the experience or the usability or increasing any of the complexity. The whole thing is fully functional and it just works. That's the point, right? But I'm going to kind of pause on this one, because this is where we really feel like everything in IT has kind of arguably been from a bottom-up approach. You have to very much so focus on the things that are very difficult or end up being difficult, whether it's through expertise or maybe the upgrades, the patching, the life cycle management of the solution itself, the scalability, or even the tuning. You really have to know and understand at a deep level how to architect solutions in order to be able to get to that outcome that you're ultimately trying to reach. And that takes time. It takes time to be able to just simply get the training. And of course, there's some argument about our talent pools today with how many people are really capable of doing this kind of thing. And again, the hyperscalers have given us that vision or that view that they're making it super simple. And indeed, in some cases they are. But why can't we do it ourselves? Is there any reason why? And it's usually because, again, as I was mentioning, cobbling all of those pieces together in order to get to that outcome. Now, if you start from the same place every time, you're rarely going to get to the top here. So as a solution, or as a thing that we're trying to do, if you consider the top-down approach, the hyperscalers themselves don't even give you the option of doing anything from the bottom up. So as a new standard, let's try to kind of flip this thing on its end. So your traditional approach to building and architecting and designing and attempting to manage that on-premises infrastructure, it's really difficult. It becomes very, very difficult to scale, or just there's a lack of agility that's associated with it in general. And it ends up, it's not nimble, it's not elastic, it's not easy. And then, of course, there's different options as well. You consider things such as, your hybrid or hyper-converged infrastructures. They appear to have some pretty good benefits as well, but again, that's kind of a bottom-up approach in general. And on the surface, it looks like they're doing the right things, but their piecemeal approach to the management of it, the functionality of the solution itself, and my favorite, death by 1,000 licenses, it ends up being very difficult to just hold on to, and there's no agility there. It's complex. And of course, our hyperscalers are also arguably coming from a top-down approach, right? But there's some integration challenges there as well. As of course, you have your data movement complexities and your management overhead, the cost considerations, and it kind of directly impedes that agility. I mean, come on, you're paying for the hardware, you're paying for the egress fees, and you're paying for the power bill. It just kind of doesn't really feel cloud-like. And so that's ultimately where we come in as a solution here. And
sorry to interrupt. I just want to remind you, you're doing 10 minutes left.
Perfect. I will talk even faster.
Let's get to the juicy stuff.
Yeah. So HyperCloud is unique technology. It provides efficient, independent and scalable processing. So from the scaling portion, think things like your storage or your compute. These two are completely separated and completely stateless, and they're able to scale independently nearly infinitely. There's no boot drive in the devices themselves, which kind of makes the physical devices ephemeral. So if there's a problem anywhere, so think a NIC failure or hard drive failure, or maybe the whole node just dies, you simply pull it out and put a new one in, and you don't even have to think about it. Now, obviously, this is not the traditional method of computing. Whenever you have a problem and you need to throw a new node in, it's going to take you a week to get it up and running. But that's not the same with HyperCloud. Because of our stateless nature, those devices are actually looking for state from the control plane. And when they boot up, they immediately do what they're supposed to do. You don't have to plug anything in or make any changes to the cluster in any way, shape, or form. Obviously, if you want to extend something or change, I don't know, the storage pools or something along those lines, you have that capability. But there's no need to go through the process of doing a lot of work in order to get it implemented. You plug it in and you walk away. So then I was asked one time, yeah, but what if I have to do 5 of these at a time? How do I do that? Well, what's crazy is you rack all 5 of them and you plug them into the control plane and you power them on and you walk away. And about 15 minutes later, they all show up in your cluster and you have the ability to consume them in an easy manner. So again, this is not that hyper-converged or what is the newfangled ultra-converged infrastructure. Every single one of the nodes is capable of being scaled independently as needed. So at the hardware level, it kind of looks like this. It's a common toolless 1U component. But every single one of the nodes themselves are built to do one thing, and that's become part of this cloud. It's really reducing that architectural burden of having to figure out how to get these things to talk to each other. In the traditional manner of doing things, you have software vendors that are making software, you have hardware vendors that are making hardware, and they say, hey, you guys figure out how to make those two work. And there's a lot of good documentation on this, and it works in some cases, but at the end of the day, you're still stuck with having to figure out that expertise in order to get it done. So we're obfuscating the hard part. Now, we've made infrastructure that is ultimately self-healing, self-organizing, and nearly infinitely scalable, as I've mentioned multiple times. But my favorite is patching. If anyone has ever gone through the process of patching one of those systems in I'll call it the legacy world, it takes weeks. And in fact, sometimes a lot of planning that is really very difficult and hard to handle and manage. Whereas with HyperCloud, you install one thing on one box, and it does a managed, controlled reboot process across the entire cloud until all of those boxes are in the same state. So we call it eventual convergence, if you will. So again, the purpose here is ultimately to reduce that architectural burden in general. Now, I've talked a lot. What is it that stands out to you guys most about what I've communicated?
I think it's the integration. That's the most difficult part, and where a lot of the private cloud offerings fall over is the integration of a bunch of different vendors, and it's all done poorly. And so, like you mentioned patching, it's a nightmare when you have to patch your private cloud.
Yeah.
Because which component and what is that going to break?
Which version for this one or this particular piece of the stack? How do I turn this into that?
Validating this one's compatible with that one. What order of operations do you need?
Yep. We've completely removed that burden. It's not usually seen from the top, maybe, but those guys that are in the trenches, it's a nightmare, and they go home sleepless, trying to figure out if they're going to have a job tomorrow because the mission-critical solution is dead because they accidentally patched the wrong thing.
I like the true hybrid approach because, like, if you look at, like Azure Stack HCI, it's going to be hybrid but work directly with Azure. If you look at EKS Anywhere, AWS Outpost, it's working directly with AWS. But with SoftIron, we can, utilize both Azure, both AWS, both GCP. I like the idea of it's, not locked on public cloud, which is great.
And the purpose comes down to the workload, right? The thing that we're trying to reach, or at least what it looks like we're doing from a cloud native standpoint, is to get to a place where our workloads are easily migrated to different places, depending on the purpose or the usage of it, right? And so if there's a change here and you want to move something anywhere else, you've already built your workload using something that you haven't tested for months on one of the other hyperscalers that could cost you thousands, if not millions, just to figure out if it's going to work. You have the ability to validate that on the HyperCloud and then burst into the cloud as you need to, or the public cloud as you need to.
If you're building your own servers, right? What about network? Is it the same built by you, like the network devices, or it's buy from somebody?
So we manage the interconnects as well. We basically provide a connection into the HyperCloud in a single uplink. But within the internals of the HyperCloud, you have the ability to separate things any way that you need to. You have complete, infrastructure as code-based capabilities to manage any type of network-based or related function.
Yeah, but like you said, you're selling that on the racks, right?
Mm-hmm.
So the racks amount. So I want 4 racks. And what type of networking you will deliver, like out of the box?
So,
right, and this is your hardware.
Correct. And again, you're coming in from the uplink into these into the cloud itself. That the burden that tends to happen, or what ends up happening from a solution standpoint, is you have different silos of not only expertise but teams that are attempting to manage things in ways that end up bringing that complexity into the solution itself, and just by the nature of what it is, increasing that complexity and reducing your agility in general. And so, depending on the speed of things that you need, you have the ability to do so. It's all over IP. We're not doing anything like with InfiniBand or any of that kind of stuff. But.
And regarding the patching, I understand that it's behaved like back in the days was a VBlock idea, right?
Mm-hmm.
The VBlock idea had something like this: network, storage, compute in one box. They deliver you that on the lorry,
right?
Basically, and the patching process is taking care. I understand compute, storage, that software that is there, but as well the interconnect part.
So in our case, we're with one binary, you're able to update the entire HyperCloud.
Okay.
And that's the other part that makes things so simple. Is at the end of the day, you don't have to worry about, as was mentioned, the different versions, or am I going to take down my entire network stack if I run this one particular patch that the rest of the solution is not compatible with?
Last question for me, and I'll shut up. Subscription or perpetual licensing? So you just buy hardware and the licenses comes with it, or you need to buy this and that on.
So it's a combination of that. So it kind of depends on what you need at the end of the day. Right.
Okay.
Quick question. You mentioned infrastructure as code. So can you?
I'm sorry, say that one more time.
You had mentioned infrastructure as code. So I was wondering, are you able to use something like Terraform?
Yes. So Terraform, Salt, Ansible, Chef, Puppet. We have Python, Ruby, and Go bindings as well. So whatever you need to do in order to get the job done.
Okay.
Absolutely.
Thanks.
I've got a follow-on question from that, but I think I'll save it because Stephen's hovering. All right. So I guess my follow-on from that is, can we come back to the workloads that you can actually run on your platform? Because we heard earlier about virtual machines and containers and such, but if I'm designing an application to run in the cloud today, Azure, AWS, whatever it might be, I'm probably not going to be using those components. I may be using containers, but I'm probably looking as, I'm looking at, the service bus or the managed SQL or the whatever it might be kind of thing. So if I'm designing a software architecture to be able to run on HyperCloud, what do I need to be aware of from that software architectural point of view? I'm imagining you guys aren't providing a lot of those services as native consumable PaaS services, as in, here's a service bus, here's a, insert one of the 200 or 300 odd services.
Sure.
Am I left to myself to build that and consume containers that have got that service within it and build the architecture around that, or how does that look?
I'll answer it this way. While we have a notion of the marketplace that provides the capability of either you or your partner or your really anyone to be able to put things into that marketplace to give you that consumable capability in that case. That's one aspect of it. It's taken some of the hyperscalers quite a bit of time to build out that service list. And we're also going to help in building some of those as well. But we're also going to work for and look for bringing partnerships in to be able to build those out
Okay.
and extend them as needed.
Got it.
It's a fantastic question.
Yeah, yeah. And that also extends a little bit onto like, the build and delivery of software, CI/CD, how's my software getting delivered into
Right.
here and how that all integrates as
That's
well.
exactly right.
So, yeah.
Yeah.
Awesome.